Right, question 14. Work out the length of the side BC. And there's BC, there's B right down there, and there's C. So we want the length of this long slopey side. Now, first thing we need to recognize is this is a right angle triangle. So that angle down there is 90 degrees, according to that little symbol there. Okay, so I'm going to label this triangle first. And the side opposite the right angle triangle is always so opposite the right angle, the 90-degree angle. That side there is always called the hypotenuse. Hypotenuse, right? And then it depends on which angle you pick, right? So we're going to pick this one here, 23 degrees. So the side opposite that then is, we can call that the opposite, OPP for short, right? Opposite. Then we've one side left, and this is the side that's not the opposite. It's not the hypotenuse. It's the side beside our angle, which is not the hypotenuse. This is beside. We could call it the beside side, but they call it adjacent, which is a fancy word for a side, or B side. If you were sitting adjacent to each other, you'd be beside each other, right? So that's the adjacent side. And now, because it's a right angle triangle, we can use sine, cosine, and tan. Now, the way I used to remember this in school was two old angels sailing over heaven carrying a harp, right? So cosine equals adjacent divided by hypotenuse, sine equals opposite divided by hypotenuse, and tan equals opposite divided by adjacent. Now, we're looking for the hypotenuse. BC in this triangle is the hypotenuse. So that rules out this guy because there's no hypotenuse involved here. And we know the opposite, which is 7 centimeters. So that makes it look like this guy would be the one to use, sine. Because sine of some angle called theta, for example. Well, it's a bad example here because there is a theta, but sine of some angle, this is a different theta, right? Sine theta equals the opposite, the length of the opposite divided by the length of the hypotenuse. So in our case, we're talking about 23 degrees. Sine 23 degrees equals the opposite 7 divided by the length of the hypotenuse. We can call it HYP. Or some other letter, maybe one letter would be better perhaps for short. But and now that's the same as sine 23 over 1. So now we can kind of like cross multiply, if you like. We can swap this guy and this guy. You know, using algebra, there's a couple of steps involved. You might want to hear them, but so we've HYP over 1 equals 7 over sine 23 degrees. So going back up here to go again, HYP over 1 is the same as hypotenuse. That equals 7 divided by sine 23 degrees. So we get our calculator and go to fraction key, 7 on top and sine 23 below. Press equals, and I come up with 17. So BC equals 17.915, and if I'm going to round that to 2 decimal places, we can call that 17.92, and our units is centimeters. Now, strictly speaking, you should have bars there because that indicates the length between B and C, the distance between the points B and C. And that's your answer, 17.92. A quick check, that should always be the longest side in the right angle triangle, and it is longer than 7. So, seems reasonable. Now, you could also draw that out with a protractor if you wanted to check it out, with an actual 7 centimeters here, and an actual angle with your protractor of 23 degrees here, and see those lines intersect, and you can measure them off then, and you should find out that this is 17.92 centimeters, and you can also work out the length of this guy using a protractor and a drawing. Anyway, that's it. Job done.